Okay, so looking at this problem, we're doing the cashew problem, and one of the things that I want you to understand is almost all of these problems fall into a basic category. Either they are a lottery problem, or they're a marble problem, or they're a whatever, a card counting, a card problem, a poker problem, um, and the what you need to recognize is what kind of problem are you looking at. Well, since this is a cashew problem, it's essentially it's a marble problem. Instead of, in this jar has one cashew and 16 chocolates. Well, so you could think of it, or 16 chocolates, but you're going to replace. Let me double check. I think it's 16 chocolates, and you're replacing one of them um, with a cashew. So there's really now going to be 15 cashews and one chocolate. So if you're try again, let's put that the right way. 15 chocolates, there we go, and one cashew. Now, so the idea here is, if you think of this as a marble problem, so you think of it this way: you have 15 black marbles and you have one red marble. So the question here is asking how many of these, when you pull them, because this is really part B, you didn't ask about part A, how many of these combinations include the cashew? So what it's another way of saying this is counting up how many different ways are there to guarantee that you have the red marble, or how many different sets of 4 are there that have the red marble. So we do this just like we would a red marble problem. We say, okay, first things first, take care of picking out the marble. Now, your mistake here, let's go through it real fast. You tried to do 16 combinations of one, and you're saying there are a total of 16 chocolates and only one cashew. So the idea here is, what you're not really picking out, guaranteeing the one cashew. What you're counting is saying, out of the 16 things in the jar, how many ways are there for me to pick one of those? We want to guarantee the cashew. So what we're going to say is, how many cashews are in the jar? Well, there's one of them, and so out of those one, we need to pick all one of them. So now that you've done that, now we say, all right, we've picked the cashew. How many things are left in the jar? Well, there are 15. And here's where you're right. There are only 15 chocolates left, and I still have to pick 3. So out of the 15 chocolates, you're going to pick 3. Dead on. Now the next issue is, you put addition between them. Addition principle means you get one or the other, but not both. That's the addition principle. It means the leather or cloth option in a car. You can't get leather and cloth. You get one or the other. In this problem, you get the one cashew and you get the 3 chocolates, and those things go together to make one handful. So this is a multiplication principle. So that's why they're multiplied. So this just ends up being whatever that number comes out to be. I mean, one combination of 1 is 1. So it's just 1 times whatever 15 combinations of 3 is, this number. And excuse me, I don't know what that number is. And so you get that, and you get your answer. I hope that helps. The bigger thing I really wanted to address here was your reasoning, because your second part of the reasoning was dead on, spot on, perfect. The first one is just the one that we need to make sure we correct. The 16 combinations of 1 means literally you're counting up everything. You're not counting just the cashew. You're pulling the chocolate number 1, chocolate number 2, chocolate number 3, chocolate number 4, all the different possibilities, and that's not what we want. We want to guarantee the cashew. So I hope that helps.